All right, I think we're live. Can you hear me? Okay. Well, good. Welcome everyone to the intro to Rook discussion. I'm Travis Nielsen. I work for Red Hat. I'm a maintainer on the Rook project, and this is my colleague Alexander.
Hi guys. Yeah, I'm Alexander. I'm working for Cloudibility. I'm with Travis and Jared to Bassam. One of the 4 maintainers of the project, and well, yeah.
Okay. So yeah, we'd like to tell you all about Rook today. Just to get a sense of what you all know about Rook, who here has at least tried running Rook somewhere in Kubernetes? Okay. A bunch of you. All right. So glad to hear people are trying it out. Who just heard about Rook in the keynote this morning for the first time? Plenty of you too. Okay. We got a good mix here. So we would like to take you through what Rook is all about and show you a demo. Well, so we just released the 1.0 Rook release. We're excited about that. It's been quite a journey. So I'll be happy to talk a little bit about that. But ultimately, we're going to talk about storage, what Rook does for storage, how it brings it into the Kubernetes ecosystem and makes it a more native part of the experience. We'll talk a bit through the Rook design, how it fits together, but then the most exciting part, hopefully, is the demo, where we'll show you a running cluster, Kubernetes cluster with Rook and what it takes to get going. At the end, how to get involved, what other Rook sessions we have. We'll have, I think, 4 sessions tomorrow where Rook will be involved.
So yeah, one of the biggest parts that, especially like every time I open github.com/rook/rook, I'm always happy to see is that we gain more stars, and well, stars are kind of like the currency in how popular the project is, if you will so. And well, we have 5.2K and it's still rising. I thought we were already 5.3. Yeah, we did the 1.0 release, which is great. Besides, well, ironically, Rook already having like, well, stable support, if you will so, for the Ceph part at least. Well, we now have hit the 1.0, which for some people is kind of the line project has to go over, but well, we're happy to those people that came because of the 1.0 especially. And well, we have over 150 plus contributors, and it's great to see, especially for some community-provided storage operators, like from the HFS guys, from Nexenta. They have done a great job, for example, with their part. We have the Cassandra with Yannis. It's great to see the community kind of step up there and help the whole Rook project there. And yeah, it's amazing to see.
Yeah, thanks, Alex. It really is amazing to see the growth of the ecosystem and what the power of an open source project can do, especially when the CNCF sees the value and is helping us back it. So we're excited. So this journey. So Rook was first open sourced actually at KubeCon Seattle, November 2016. It was a little bit smaller. About 1,000 people were there on that occasion. Nobody had ever heard of Rook, even at the conferences, no talks or anything. So we had 0.1 release with that open source event. And then since then, we've released roughly a quarterly cadence until now we're at the 1.0. And it's just, we're going to keep on going on this cadence and yeah, just having fun delivering features, bringing storage to Kubernetes. So let's talk about what storage involves with Kubernetes for a minute. So traditionally, Kubernetes applications, we assume they're stateless. They're designed to just, it's running here, kill it, run it over there. Great, we treat them as cattle, and everybody's happy. But what about the applications who need storage? Traditionally, you buy your storage appliance, you plug it in somewhere else, you manage it somewhere else, and it's outside of Kubernetes. Then there's this volume plugin model for Kubernetes that lets you attach your storage that's external to Kubernetes. Whether it be, if you're running in the cloud, Azure, Amazon, if you're running on premise, maybe you've got Ceph or Gluster running, but that's the traditional model for working with storage with Kubernetes. Okay, so this comes with certain challenges, of course. The storage is this separate animal that's on the side. You can't treat it just like your other Kubernetes applications. Well, we thought, well, why is that? Why can't we just treat storage as another application in your cluster? It's a separate deployment burden. We don't want it to be separate. We want it to be the same model. You might have vendor lock-in, right? These storage appliances lock you into that solution. You have a different solution, whether you're running on premise or in the cloud or wherever. So, the question to ask ourselves is, how do we get a consistent story across all clouds or on premise? And how do we get storage that follows the same pattern, the same solution, whether or wherever Kubernetes is running? Okay, so this is where Rook comes in. With Rook, what we did is we created a set of operators that will run storage applications in Kubernetes. And we'll talk about what those specific operators do. But really, there are two different categories that these operators and what Rook will do for you. First of all, it's about automating the deployment and management of the storage for you. So you need to deploy the storage. You start up, you bootstrap it, you configure it. You need to upgrade it over time. This is a whole set of problems which you want to make sure is automated, and you don't want to have to manage it any differently from other Kubernetes applications. Okay, so that's the first thing, managing the storage. You need a management layer that works well with Kubernetes. The second thing is really provisioning of the storage. That means using the Kubernetes volume plugin model to attach the storage with the PVCs. So that mainly involves, right, you've got a PVC, you've got your pod that needs to consume the storage, so you declare your PVC, Rook binds it then to the Ceph storage, and attaches it with the volume plugin. So even though the storage is running inside your Kubernetes cluster, Rook can attach it with just the same volume plugin model as we've seen elsewhere. So a little more about Rook. It is fully open source, Apache 2.0 license, and it is an incubation project for the CNCF, as you saw on stage this morning. It extends Kubernetes with operators, with custom resource definitions, and it is a framework for bringing many storage providers and solutions. So which storage providers are we talking about? Where we started the project was with Ceph, and that's why we were happy to announce in our 0.9 release, so back in December at KubeCon, that we declared Ceph as stable as part of Rook. Okay, so that's, Ceph itself has been in production for a long time, but the integration with Kubernetes we declared as stable. EdgeFS is another operator that recently has been integrated with Rook, and in the 1.0 release was just declared as beta. So go check that out and see what it's capable of. Other storage services similar to Ceph. Cassandra, CockroachDB, Minio, NFS. All of these are in alpha. Some of them have been in Rook for a couple of releases. It's just about community involvement. It really depends on the community to get involved, and whatever storage they need to come get involved and help us get these things to stable in the Rook project. So yeah, anything else to add to that, Alex? Just the storage providers?
Well, besides that, as we already had said earlier, like with Cassandra and so, there's been amazing work from the community. And we also have some other storage softwares have come up and, hey, can we integrate in some way with with Rook there? So again, it's amazing to see the community there. So yeah.
Yeah. So if you know of other storage solutions that would make sense that need to be automated with Kubernetes, use the operators, we'd like to talk and get you integrated as well. So what are these operators that we're talking about, this pattern? You may have heard about it for the last couple of years, or maybe it's completely new. At the end of the day, it's about taking what you need to deploy and creating automation around it. and do it in a way that it looks like any other Kubernetes application. And custom resource definitions are the way that Kubernetes allows us to do this. So an operator will sit in what's called the control loop, and it watches and it says, what would you like to do? Oh, you'd like to create this type of thing, like a Ceph cluster. Okay, I'll go create that now with the settings that you've described in your manifest, or this YAML file, which just like you define other pods and deployments and anything else in Kubernetes. So as it observes what you desire to happen in your cluster, the operator goes and makes that happen. And automation is a good thing. The other effect it has is it simplifies your life as an administrator in the cluster. You just don't have to worry about all of the individual storage settings for your storage. You can let Rook take care of that for you, apply some smart defaults, but then you can also override those defaults and change those settings when you need to. CRDs, I guess I already mentioned, it's all about what settings do you want, and then the operator makes it happen. Okay. And so let's skip over this. All right. So the operators leverage the full power of Kubernetes. That's where we really took a bet early on in Rook, where we said we believe Kubernetes is going to grow, and amazingly, it's been amazing that way. And let's build everything around Kubernetes. So that's the only storage provider, the only orchestration platform that we cater to. It's all about Kubernetes. Generate services, use replica sets or daemon sets, deployments, secrets, all of these things. The operator talks to the Kubernetes API to apply these settings. We don't worry at our level at Rook about what do you have Docker running? Do you have what's underneath the covers? Do you have systemd? It's out of our hands. It's just standard Kubernetes. Now also note that the Rook operators are not on the data path. So the operators are just the management plane, and whatever the storage provider is under the covers, that's what provides your data. Whether it's the database, they're serving the data directly, or at the file object or block layer, talking directly, your PVCs talk to them at that layer. Okay, so to show a picture of this, what we have is on the left, your standard kubectl tool, where whatever you want to create, you say, or whatever you want to know about the cluster, you're creating it, you're querying it. So with Rook, again, you're just going to be able to say kubectl create your YAML file, your Rook cluster, and the same tools you're already using, and the operator will work on that. So now the operator's on the right. So we have one operator for each storage provider. So we need more pictures here. We've only got a few of them. So it's like Ceph, Cassandra, EdgeFS, all of them, they each have their own operator. And then they have the drivers that work with the Rook agent, or CSI, to attach your storage with the PVC. So kind of, all coming together. Overall picture is operators talk to the Kubernetes API to create these resources and use the CSI or other drivers to attach the storage from your pods. An example with Ceph. So I do work with the Ceph team at Red Hat, so that's what I'll be focusing on for the demo today. Tomorrow in the Rook Deep Dive, definitely come back for that. There will be more talk by other maintainers about the other storage providers that Rook has. But for Ceph as an example, there are a bunch of settings that we need to know about your cluster. What version of Ceph do you want to run? Because that's a different version from what version of Rook. How many Ceph monitors do you want to run? The smart thing is, well, you need at least 3 so you can have a quorum. Do you want it to run with host network? For storage, do you want to use all your nodes? Anyway, and so when you create this YAML, this manifest, Rook will go out to it'll say create pods, create the mons, create the OSDs, all these. If you're familiar with Ceph, you'll recognize these. If not, just know that there are these storage daemons being started such that the storage platform will be available to consume from your PVCs. And in this picture, note that there's really only the Rook operator, which is the little blue castle there. There's only one or a few of these pods running. The rest are really the storage layers daemons, so the Ceph daemons in this case, running where there's not any Rook in that code path. All right, so you create your YAML, you get pods and other services. All right, we kind of touched on this already. So Rook is a framework for other storage solutions. And what we get in common, we really get patterns around how to create operators. There's some common code that helps these operators work with the different Kubernetes APIs. There's a common testing effort because you need reliable storage. You need storage that's durable. So the testing framework really helps make sure that things are well tested before release. All right, so let's go to a demo. I'll switch over here. And all right, what does this look like?
Is it visible for you guys at the back from size? Is it good?
I think I need to adjust some things since things changed with the display here. Sorry. Should have done this before. Okay. All right. So I'm going to make this a bit bigger. Now, what I have here is, so some colleagues at Red Hat have created a nice demo environment that makes it easy to spin up a cluster to show. It is an OpenShift cluster, but I'm going to use Kubernetes commands as much as I can since it's pretty much the same thing from our perspective. Now, the SSH did disconnect. I need to SSH into it because it is running in the cloud. So you can all see my password now to SSH in here. I'm going to destroy it right after this, so I'm not too worried. Hopefully nobody connects and disturbs the demo while I'm going. All right.
Well, the whole thing is live streamed, so be fast.
Okay. No. All right, let's make sure what we got here. So kubectl get nodes just to see if we're connected. All right. So in our cluster, we have 4 worker nodes, a couple of masters. So what I've done is I've pre-configured the YAML files, our manifests, so that we'll start storage on and consume the storage on 3 of these nodes. Okay, so I'm going to go over here. Clear. All right. Now, let's see. All right. So I've got these YAML files. I'll create them one by one and describe as I go. So kubectl create common. Is that big enough, or should I make it bigger? Okay. Okay, so common.yaml, when I hit create, it's going to create the security settings, the RBAC, all these service accounts that Rook needs. Rook needs to have privileges to run pods privileged, for example, because the operator needs to start these daemons, which consume local devices, real hardware on the nodes. So we do run some pods privileged for that purpose. So we've got this. Now, we don't have any pods yet, just to confirm. All right, no resources found. So now I'm going to go ahead and create the operator. Create operator. And this is OpenShift. There are several settings specific to OpenShift. But before I do that, let me say watch kubectl get pod. All right. Now, hopefully when I create the operator, we'll see the pod start to appear. All right, there we go. So the operator is the first pod to start. And immediately, as soon as it starts, it's going to create several other pods on our storage nodes so that we can detect what storage devices are available and also start an agent which will help us attach the storage later. This is currently using the Flex driver for Rook, which will attach the Ceph storage. All right, so all of these pods are running now. We have our agents, we have our operator, and the operator is just waiting for us to tell us what kind of Ceph cluster to create. So let's go ahead and do that. So if I say kubectl create cluster.yaml, so this is the YAML that has all the settings I showed on a couple of slides ago that tell it what version of Ceph to run. So the first thing it does is detect, oh, what version of Ceph do you want to run? In this case, it's going to detect Ceph Nautilus, which was just released a couple months ago. The next thing it's going to do is going to create some Ceph keys, save them as secrets in Kubernetes. Then it's going to start creating these Ceph monitors. Okay, who here has deployed Ceph independently from Rook? Anybody? So you probably know it's not very easy, or at least not as easy as this, hopefully. That's why we created Rook, to make it easy. But you need 3 monitors, so it's going through one by one. It's making sure they're in quorum each step of the way. After we have 3 monitors, so just in a few more seconds here, so we see, okay, we have Mon A, Mon B, and Mon C. So once those are all in quorum, then it will create the Ceph manager as the next pod. That will initialize some Ceph manager plugins and modules. And then we'll get our OSDs, which are the storage daemons that will really create the storage platform that Ceph is going to serve up from each of the nodes and make it look like this, the software-defined storage system. Okay, so we have the manager now. While that's going, so we'll see the OSDs start to come up in a minute. I'm going to create a couple of other resources that will help us see some things in the cluster. Okay, so the OSDs are coming. We have what's called a toolbox pod. So what this pod is it's a convenient place to go run any Ceph command you want. So anybody knows that sometimes you need to go run Ceph commands. So the toolbox will let us now connect, see Ceph status, see Ceph OSD status, anything like that. Okay. Now that we have the toolbox, we have our OSDs. Yeah, let's go back to OSDs. So we see right here that we have 3 OSD daemon pods. They're running on each of our 3 nodes. Okay, they're ready to go. So let's connect to the toolbox now and see the status. So we're going to say, for convenience, I'm going to connect with OC to the toolbox. All right, I need the pod name. Okay, so we're inside the Rook toolbox now, and we can run Ceph status. And we see the cluster is health okay. There are 3 mons, 3 OSDs. We don't have any pools yet, but we have a basically healthy cluster. So now I'm going to go back, and now to consume the storage, the second part of Rook, we need to create a storage class. So let me just show you what the storage class looks like. So along with the storage class, we have a Ceph block pool. And in that pool, the interesting thing is you can tell it how many replicas of your data do you want in the cluster. Or if you're familiar with erasure coding, it can configure erasure coding as part of that pool. So for this demo, I said, let's create 2 copies of the data. Okay, for the storage class, which is in the same YAML, we tell it, okay, my Rook cluster is in this namespace. When you mount the storage, use XFS. Oh, and I skipped over the block pool. And the pool that this storage class should use is the replica pool, which was the pool I just showed you with replica 2. Okay, so let me exit this and go ahead and create that storage class. So now I have the storage class. Let me just show that. Get storage class. And we have this thing called Rook Ceph block. OK. So we're now in a position where we can create a PVC to go consume it. So a standard kind of demo that we have is, and in our quick start guide, is to go start a WordPress application. Just a really simple thing, and it needs a MySQL database so that it can have persistent storage. Now, let me just show quickly what that looks like in the YAML and show where the PVC is. Let's see. So in this MySQL YAML, we see a definition for a persistent volume claim. And we're requesting a simple 20 gigabytes in read-write once. And it comes from this storage class, Rook Ceph block, that we just created. Okay, and then later in this, you'd see the pod definition that uses this PVC so that you can mount it into the MySQL pod. So with that, let's go ahead and create two YAMLs. So I've got a MySQL. I'll just go ahead and create the other one. And we've got WordPress. Okay, and at the bottom, well, these may scroll off. Let me make this bigger. So we've got two pods that are starting up. And as soon as that storage, that PVC is bound and mounted, we'll see them in running state. Okay, so now we have WordPress running in this state where it's ready and available. Now, the WordPress does take a couple of minutes to start up, initialize the database and things. So in a couple of minutes, I'll open it up in browser and we'll double check that it's actually running. But that's basically in a nutshell. So you've got storage orchestrated by Rook. It started a Ceph cluster. It then allowed you to define the PVC, which mounts from the storage class and gives you this storage. All right, so this, while that's going, what we will see if I get the services, so the WordPress app creates a load balancer service that will be at this URL. Since it's running in AWS, it just gives me this nice URL. And let's see, where did my browser go? Oh, I'm in presentation mode. So now, this probably won't work yet because WordPress is still initializing, but we'll come back to it in a minute and talk about that. So why don't we go back to the slides for just a couple of minutes, give that a minute to go, and we'll go from there. Let's see if I can find the present button. All right, Alex?
So we have seen right now that it's pretty easy to, well, especially in a test environment, create a Ceph cluster for storage. But kind of think about it more or less as a use case for, let's say in my case, I have some bare metal servers, but I don't have money to buy more servers for, well, exactly for storage. So I could just go ahead, run my applications with Kubernetes as containers, and just, well, put Rook Ceph on there and have my storage there too. Like, well, if the applications at one point use too much load of the servers, then yeah, you will run into some issues there. Well, storage in the end is also just another application running. But it could, for example, in this case, help me so long till, for example, I would get more funding from a company or something to get more servers. Just kind of as an idea where it could also be used as a use case there. And, well, you showed it with directories, but the same goes for disks. If you have some raw disks at your servers, just point the Ceph cluster object to them, and they will be used for the Ceph cluster. Mm-hmm. It's, well, especially also for bare metal in mind, it works.
Yeah, and you're running it at home, right? It's been working for you for a long time?
Yeah, I had like, I think one of the longest running clusters, not the longest, but from like version 0.6 on to like 0.8, 0.9. And well, the only reason why the cluster isn't the longest running now anymore is because I, got new hardware and just scrapped everything and started over. So, maybe someone else does it like this, starts a new version kind of with Kubernetes and just resets to 0 to rebuild what you learned till the adventure there. So, well, it's fine, not only for me, some bigger people like some bigger universities, I think it was Hamburg University in Germany.
Yeah.
And there are some other bigger universities in US, like, you know who I'm talking about, right?
Yeah.
The supercomputer.
UCSD, I think.
Yeah, the UCSD. They're using it, for example, too, which is simply awesome to see that it's well, not only applicable for like smaller use cases, like in my case with like 7, but also for bigger, well, universities, also companies. There's also a good amount of companies using it, and already in production for those of you going like, hey, can we use it in production? Yes. There are a lot of people already since like, I think I heard like at 0.3, 0.2 or so started using it.
Very early.
Yeah, it's
not 0.3, I hope, but maybe 0.5.
Yeah.
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 All right. So back to the WordPress. So this is the website. It's up now. We don't really have time to go through and configure it, but it is backed by the Ceph storage that was orchestrated by Rook.
If you would set it up now and create a blog post on it, like, hey, hello KubeCon, and we would go ahead and delete the MySQL pod, and well, the new MySQL pod would be created, we would get the same data as, well, we have the Ceph cluster behind it. So,
yeah. So just in conclusion, we'd love to hear your, help you get involved with Rook, try it out and get involved. If you want to cover that, Alex? Yeah.
Yeah, so, well, if you want to use it as a user, best way would be to go to rook.io. We have a big documentation link at the top. If you go to it, there's like a link to the Ceph getting started guide, but also for the others like HFS, Cassandra, and so on. And well, hoping that you not run into any issues, but still, if you should run into any issues, we either have the GitHub project where you can create issues, or just hop on the Slack and, well, ask or say that you have an issue. Yeah. Besides that, if you want to get involved to, well, for example, as you said, with a new storage backend, maybe even possibly, we have community meetings together. We have GitHub, so creating an issue there, like, hey, I want to integrate this and this, is always welcome. And we even have a mailing list if you're interested in that. And yeah, as already said, like a Slack, and yeah.
All right. Yeah, so we have a few more sessions that talk about Rook. Here they are. Hope you can make it to them tomorrow. And we'll be here for questions. I think the keynotes are starting soon, but maybe we could have time for a question or two. All right? Yeah. Is the question if the OSD pod is co-located with the disk? Not really. Yeah. So the OSD pod is attached. It uses a node selector to be tied to that node that has that disk on it, so that Kubernetes won't fail over the OSD to another node because it's tied to that disk on that node. Yeah. Okay. One more question, maybe? Okay.
Is it possible to set configuration settings for the OSDs for like backfilling or anything else, or only on the fly on the CLI?
Okay. Yeah, so the question is if you can apply more OSD backfill settings or other OSD settings. Yeah. Yes, it is possible to apply any Ceph settings for the daemons. There's advanced documentation on the site that says how to do that. Basically, you set the Ceph settings in a config map, and then when Rook creates the pods, those pods pick up the settings from that config map. All right. Well, thanks a lot, everybody, and let us know if you have questions. Stop by the Rook booth anytime this week, and we'll talk more.
I hope the number of the roof is up there.